Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq Amir bin Muhammad Nasri. My matrix number is CD190294 and my supervisor's name is Dr. Hanis bin Zakaria. And today I want to present about my thesis. The title is Dust Exposure from Sandblasting Activity. Firstly is the introduction. Okay, in this slide, it shows a worker doing abrasive blasting activity in the open area. This action is non-suitable because it can produce air pollution to the environment. For background study, the definition of abrasive blasting is to use compressed air, liquid stream, centrifugal wheels, or pedals to push a stream of abrasive materials at high speed onto a surface to clean, abrade, etch, or change the original look or condition of the surface. Abrasive blasting can have a significant influence on the environment, cost, and the health and safety of employees, including air pollution, contaminants and blasting media waste disposal, hazardous waste, and noise from blasting machines. Silica is a compound of silicon and oxygen that contains at least 95% silica oxide and less than 0.6% iron oxide, making it one of the most dangerous compounds in silica sand in terms of concentration and potential health effects. The abrasive material and the surface being blasted may contain toxic compounds, which is lead paint silica, that are hazardous to employees. For example, silica sand can cause silicosis, lung cancer, and breathing issues. For problem statement, silica sand that comes from blasting activity is the impurity in the air around in the industry site. Besides that, silica dust is very small crystalline silica that can easily travel deep into the lungs, and human will risk lung cancer and even silicosis. Silicosis is a fibrotic lung disease caused by silica exposure. Employees quickly inhale the silica dust because the particle silica dust is microscopic. According to Occupational Safety and Health Administration, this situation is hazardous because it can cause death cases. When these tiny emissions dust particles pollute the air, the consequences for the ecosystem can be disastrous. These emissions can have such a negative impact on the ecosystem that they can disrupt weather patterns, induce droughts, promote climate change, and even cause the oceans to acidify. Particle emissions into the atmosphere contribute to the greenhouse effect, which traps heat in the atmosphere and prevents it from leaving the Earth. The objective of this study is to measure dust release from abrasive blasting activity for surface cleaning. And in my scope of study, the abrasive blasting in this study is for surface cleaning. Second, the abrasive media used in this study is garnet, which is the media normally used for cleaning process. Third, used under the Occupational Safety and Health, use and standard of exposure of chemical hazards to health, Regulation 2000 as reference, Factories and Machinery Mineral Dust Regulations 1989 as reference. For significant study, the significance of the study is to examine the exposure of workers to inhalable and respirable dust at sandblasting sites. Examining the exposure of workers to this dust at sandblasting sites can determine the effect of dust on the lungs workers. This study is based on the Occupational Safety and Health Act 1994, Use and Standards of Exposure of Chemical Hazards to Health, Regulation 2000. All the chemical substances that are hazardous to health already have a list. This study helps workers aware of the endangerment of fine dust, and it can be used for references in the future. And the second topic is literature review. Abrasive blasting is the process of driving a stream of abrasive material at high pressure against a surface to smooth rough surface, roughen a smooth surface, shape a surface, or remove contaminants. The media is propelled by either a pressurized fluid such as air or a centrifugal wheel. An abrasive blast system is usually composed of three parts, which is blasting pot or an abrasive container, mechanism or propelling device, lastly nozzle for blasting. In this slide, as we can see, a worker standing holding a blast gun and pointing towards other way. That is the process for abrasive blasting. On the left bottom of the slide is our media that we will use for this activity, and the middle one is a container that we will use to blast a surface or a pressure vessel tank on a closed area. On the top right corner is our compressor, and the last picture is our suction blast gun. Next is health effects. We can get respiratory disease if we expose to this fine dust, which is irritation, fibrosis, COPD, asthma and lung cancer. We also can get chronic bronchitis, dermatitis and silicosis. Difference between inhalable dust and respirable dust. For inhalable dust, the particle that can be breathed into the nose or mouth under 100 microns in diameter. For respirable dust, a subset of inhalable dust covering any fraction of inhaled airborne particles that can penetrate beyond the terminal bronchioles into the gas exchange region of the lungs, under 10 microns in diameter. As we can see, an inhalable dust particle is 100 micrometer. A respirable dust particle is 10 micrometer. A respirable dust is smaller than an inhalable dust. The next is standard legislation in Malaysia. This is the hierarchy of legislation in Malaysia, which is acts, regulations, orders, code of practices and guidelines. The Factory and Machinery Act of 1967 and the Occupational Safety and Health Act of 1994 must be followed in Malaysia to protect workers and the public from OSHA events. The Department of Occupational Safety and Health Malaysia, which is known as DOSH, enforces all safety and health laws. The Department of Occupational Safety and Health ensures people's safety, health and welfare in Malaysia. This group protects workers from several hazards. DOSH provides suggestions, policies, statutes, and ethical principles to protect workers in the workplace. The statutes that followed FMA 1967 were Mineral Dust Regulation 1989 and Use and Standards of Exposure to Chemical Hazards to Health, which is known as USECHH Regulations 2000 from OSHA 1994. The Occupational Safety and Health Use and Standard of Exposure Chemical Hazards to Health Regulations 2000 were enacted to establish a legislative framework to restrict exposure to chemical hazards in the workplace. The purpose of this regulation is to establish a standard for worker exposure to toxic chemicals in the workplace. This is according to the number 1 substance defined as radioactive under the Atomic Energy Licensing Act of 1984. Second, foodstuff. Third, substance hazardous to health solely by virtue of their explosive or flammable properties or solely because they are at a high or low temperature or a high pressure. And lastly, pharmaceutical products. Okay, and I will talk about the class regulations. The class regulations supersede the occupational safety and health, classification, packaging and labeling of hazardous chemicals. Regulations 1997, CPL. The class regulations ensure that providers of hazardous chemical provide proper information on their risks, reducing the likelihood of workplace accident and providing a safe and healthy working environment. The class regulation requires suppliers to categorize, label, create safety data sheet or known as SDS, package and provide chemical inventory data, principal suppliers, those that generate, manufacture, import, recycle or reformulate hazardous chemical substances, and subsidiary suppliers repair, distribute or retail hazardous chemical. Next is palm oil in water emulsion. Emulsification is used to make many consumer goods. An emulsion is a thick homogeneous mixture of two immiscible liquids and a mixing agent. This is an emulsifier. The final component is energy, which is usually given by shaking, blending, or agitation. An emulsion is a mixture of immiscible liquids and a surfactant. Oil in water and water in oil emulsions are common. Emulsions are used to make milk, yogurt, mayonnaise, salad dressings, shampoos, conditioners, and other products across industry. Homogeneous milk consists of lipids, oil dispersed throughout a water-based matrix, skim milk. Once these two incompatible substances are joined, milk proteins work as emulsifiers to stabilize the mixture so it can be used. Emulsions consist of a polar aqueous liquid phase and a non-polar oil liquid phase. The interior and/or external phase of emulsions determine their kind. In the picture, in the A section is oil in water emulsion, B is water in oil emulsions, and C is the multiple emulsions. And the third chapter is methodology. We are using dust monitoring in this study. On the left side of the slide is sampling pump. The middle one is our cassette that we will put into the aluminium cyclone, which is right bottom of the slide. We will using a filter. Type of filter is PVC and MCE. Okay, on the top right corner of the slide is sampling pump calibrate with the pump calibrator. Okay, the function of the pump calibrator is to find the correct F to find the correct flow of the sampling pump when we use to monitor the dust release from abrasive blasting activity. The method is very simple with little error and allow users great flexibility in selecting airflow from 1 to 4 liters per minute. The method is routinely used for collecting all kinds of particles from metal shavings to pharmaceutical dust. The NIOSH 0500 method is a default method for dust sampling in this study. In other words, if you need to collect the dust and the sampling procedure is omitted from the method, by default it is the NIOSH 0500. For the NIOSH method 0600, the normal operation flow rate is 2.5 liters per minute after being on the market for 20 plus years. The aluminum cyclone became a common sampling device where larger volumes of air were needed. The cyclone is listed in the NIOSH 0600 method. The sampler is best suited for silica sampling when the result must be compared with ACGIH procedure. And that's all from me. Thank you.